In today's video, I want to start by looking at 5 skills that the McGraw-Hill book, Top 50 Skills for a Top Scorer, gives you. In the back of the book, there are certain flashcards, and these are part of those flashcards. They skip skill 2. I don't know why. Maybe I'll run across it as we are going through these. But I wanted to point these out to you. So if you would take note of these, I would write them in my notebook if I were you. They're really, really helpful, I do believe. Let me get my marker up here. All right. Skill number 1 tells us that when you see a variable or an unknown in the question, in other words, if you have X's and Y's, A's and B's, so forth, and at the same time all the answers listed are numbers, then in all probability a good approach to solve that particular problem would be to plug and chug, as y'all say. Use the answers, plug in, and find the problem that works. Now, we're not guaranteeing that every time that's going to work, but that is probably the best place to start to save you some time. So when the question has variables in it, but the answer is all numbers, then plugging in numbers and trying to see which one gives you the correct answer is a very good place to start. Secondly, if the question asks you something as like this, what is M in terms of P and Q? That's a fancy way of saying solve for M or use algebra to get M alone. Okay? What that means is solve for the M, and you're going to have P and Q in your answer. You're not going to have just a plain old number like they suggest in Skill 1. Okay? It means you're going to have a variable on one side, the M, and on the other side, you're going to have something going on with the P's and Q's. 2P minus Q, or 7P plus 4Q, or something like that. So you're isolating your variable of M and basically turning it into your equation into a formula that solves for M. All right, and there's skill 4. When you see the word mean or average on the ACT, you use the formula for average that you learned in elementary school. That the average equals the sum of the items in a list divided by the number of items in the list. It's the way that we find the average for your grade. Okay, that's I always tell my kids to remember, a mean teacher takes your average. Okay, so remember that mean and average are synonymous on the ACT. Skill 5, when you see vertical lines, a linear pair, or a triangle, calculate the measures of all the angles. This is so you don't get caught up or tripped up in not answering the question that was asked. So I'm going to quickly go over vertical angles and linear pair. Those of you who have not had geometry, you will have this early on in the year next year. So you can be watching for that. But with vertical angles, get the right tool up here. Okay, vertical angles are what we call non-adjacent angles formed when two lines cross. So the angle that I'm marking there, which I'm going to label angle 1, and angle 2 are vertical angles. Vertical angles are equal to each other. So whatever the measure of angle 1 is, that's going to equal to the measure of angle 2. So if angle 1 is 70 degrees, angle 2 is 70 degrees. If angle 1 is 179 degrees, angle 2 is 179 degrees. Okay? But if we can look beside of these angles that I'm marking in yellow, we'll name those angles 3 and 4. Angle 3 and angle 4 are vertical to each other. So angle 3's measure will equal to the measure of angle 4. My little m's there mean measure of. Okay, so 1 and 2 will be equal. And then in an entirely different capacity, angles 3 and 4 will be equal. Now what we can also gather from these takes us into the linear pair that they have suggested on our second piece of information here. So let me make 2 more cross lines. So I've got a line intersecting a line. Now this time where I'm going to mark angle 1 and angle 2, these are not adjacent, so they're not equal to each other. But if you see when I put the angles together, that angle, when I cozy it up right next to angle 1 there, those 2 angles make a straight line. So when you have a linear pair, do you see the word line there? A linear pair is going to make a straight line, and that means that they're going to add up to 180 degrees. Okay, so if I take this concept and go back over here, I'll see that angle 1 plus angle 4 equals 180 because they're a linear pair. Angle 4 plus angle 2 equals 180 because they're a linear pair. Angle 2 and 3 equal 180 because they're a linear pair. And angle 3 and angle 1 equal 180 because they're a linear pair. Those two, and then these two, and then these two, and then those two. Okay, so in other words, they're wanting you, when you find one angle in your vertical angles, find all 4 of these. And in my red here, when you find one angle in a linear pair, find both, because that might be significant to your problem. In a triangle, always remember that the angles of a triangle, and of course there are always 3, those 3 angles are going to always add up to 180 degrees. Okay, so keep that in mind. Let's see our last card for today. All right, skill 6. When you see 2 parallel lines that are crossed by another line, then we have 8 angles formed, and these 8 angles have relationships. We like to say in geometry class, when you have 2 parallel lines cut by a transversal, you have 8 angles formed. Now, in our geometry book, our symbol for parallelism is you take the 2 lines and you put these little arrows on the lines, and that indicates those 2 lines are parallel. I don't believe that that's the way it is on the ACT. I believe they're just going to tell you that they are parallel. They may use the word parallel, or they may use the symbol. I'll label these line 1 and line 2. So they may tell you line 1 and then use this symbol for parallel. So they may tell you line 1 is parallel to line 2, either with the word or symbolically, or in our textbook, we use the symbol here. Okay? Now that leaves this little guy, this little cross figure here, to be my transversal. I'm going to label him with red. So he's my transversal. He's going across the other 2 lines. And you can see here we've got 8 angles formed. Let's number them in blue. 1, 2, 3, 4, 5, 6, 7, 8. Now, a few minutes ago, we said that vertical angles are congruent. So that means that 1 is congruent to 3, and it means that 2 is congruent to 4. But what you need to know is the other angles, the other 4 angles are going to have that exact same pattern. So 5 is going to be congruent to 7, and 6 is going to be congruent to 8. So my 4 angles that I have marked in red, which I purposely labeled as the even angles, 2, 4, 6, and 8, those are going to all have the same measure. And then 1, 3, 5, and 7 are going to all have the same measure. Okay, that will work, but only when the lines are parallel. If the lines aren't parallel, then those equal relationships do not exist. All right, you have some problems to work. I've given you, the sheet is attached. I don't have these on here very good, do I? Let me see if I can get my old sheet out. Okay. All right, number 1 asks, what is the greatest common factor of 30, 90, and 130? What is the greatest common factor? Now, our greatest common factor is always the largest number that divides evenly into 2 or more numbers. So it's like if I take an algebraic expression that has a 30 and a 90 and a 130 in it, and I say, okay, I need to factor this. What would I factor out? When I ask myself, what would I factor out? That is asking myself, what's the GCF? Okay? So the GCF is what we find when we're factoring. So we want to find the largest factor that will go into each of our numbers. It's got to go into 30, it's got to go into 90, and it has to go into 130 evenly. There may be more than one, but we want the biggest one. We want the biggest one. So as I look at these, I'm going to use some of the tools that I learned at elementary school. These all end in 0. So I already know that 10 is a common factor. Now I don't know if it's a greatest common factor, but it is a common factor. Now let's see if anything larger than that will go into our numbers. Now look at the choices that we're given. We're given 2, 3, 5, 10, and 30. Well, we already know 10 works, so we know we can eliminate those because we're looking for the largest. Now we just have to check and see, does 30 work? Well, 30 does go into 30 evenly, and it goes into 90 evenly, but 30 does not go into 130 evenly. So that makes us reject 30, and we know then that 10 is our greatest common factor, and that's answer D. For number 22, we have an absolute value problem, and I wanted to remind you, the reason I picked this one, remember when you're using absolute values, pretend that the absolute value symbol is a grouping symbol, because basically it is. So let's rewrite this. I'm going to change colors so it doesn't run into the other problem. Now they tell us to replace x with 7. Okay? And we're supposed to solve. Now when we solve these, we are not going to take the absolute value of each digit or each number that we have inside the absolute values. We're going to use the order of operations to solve inside the absolute value symbols, and once we get that answer, that final answer, we're going to take the absolute value of that answer. The absolute value is how far something is from 0 on the number line. So you can go 2 miles to the left and 2 miles to the right. You're still going 2 miles. Okay, so we're not worried about direction. We're worried about distance. So as I solve this, I'm going to get -2 times 7 is -14 minus 5. And then over here, -4 plus 8 is a +4. I'm still working inside my absolute value symbols. I'm going to have -14 minus 5 is -19. Now I'm going to take my absolute values of my digits or my numbers because they are now inside alone. There's no more arithmetic to be done. How far is -19 from 0 on the number line? Well, it's 19 units from 0. And I'm going to subtract from that, and I'm subtracting. That is not in absolute values. So don't just change that to plus because it's an absolute value problem. How far is 4 now from 0 on the number line? Well, it's 4 units. So when I subtract those, I'm going to find that when I plug in 7 for x, I'm going to get 15. Okay, 24 and 25 have us using the same chart. And let's see what 24 asks. Well, let's read the whole thing because it gives us pertinent information. Use the following table to answer questions 24 and 25. It shows the class level of the 500 students at Greenville High School. So they've told us the total is 500 students. What percentage of students at Greenville High School are seniors? So we go to our table and we look in the seniors, and we have 120 seniors. So 120 seniors out of that 500 seniors is going to be our ratio or our fraction. But remember, fractions and decimals and percentages, they are all first cousins to each other. Okay? So we can go from one to the other. And with your calculator by your side, this is a very easy problem to solve. If you have your calculator, you would immediately divide 120 by 500. Please, please, please make sure when you plug this in your calculator, you plug the correct number in first. The 120 is being divided by 500. It's not big number divided by small. It's top number divided by bottom number. And when you divide that on your calculator, you're going to get a decimal of 0.24. But the question doesn't ask for a decimal, it asks for a percentage. So when you look over at your possibilities, you'll be able to see how the decimal has been moved 2 places to the right to convert from decimal to percentage. So we're going to have 24% or C for our answer on 24. All right. Another thing to think about for those of you who are really concerned about changing this to something over 100%, over 100, you can still do this if you want to by cross multiplying. Multiplying 120 by 100 divided by 500, you should get 24, and then you would have your percent. So if this is the way that you are the most comfortable, you can work that problem either way. The second problem down here, number 25, goes with our chart as well. If the fraction of students who are freshmen is represented using a circle graph or a pie chart, what should the measure in degrees of the central angle of that portion of the graph, okay? So what they're asking us, if we're going to convert the information in our chart to a circle graph, if I'm going to change it so that I'm going to divide this up, juniors, seniors, 9th grade, 8th grade, whatever. If I'm going to use this type of graph, then what is my angle going to be when I'm looking at the freshman class? Well, let's look at the freshman class first. The freshman class up here has 125 kids in it. So 125 out of the 500 students is the fraction that we have of freshmen. Well, that's a quarter of our students, 1/4 of our students. So since I'm converting my information in my chart to a pie chart, see if I can make this look a little bit prettier. That's a little bit better, isn't it? 1/4 of the circle is going to represent the freshman. So let's put my center to my circle in here. And if I make 1/4 of this, this is my 9th grade class right here. It's 1/4 of the kids in the school. Now they've asked us for the central angle. That means it's this angle right there. Central angle has its vertex at the center of the circle. So they're wanting to know what degree measure would that have to be. Well, since we know, or we should know, or we are now learning that there's 360 degrees in any circle, then if I take 1/4 of the 360 degrees, That gives me 90 degrees as my central angle right there. So when I look down at my choices, I see that E has to be my choice because it's the measure of the central angle. It's 1/4 of a circle, or 1/4 of 36, or 360 rather. Okay, let's look at the last ones and we'll be finished with this little section. I chose several graphs this time because we don't talk about them very much after you get to high school. And even though I believe that you're pretty comfortable with them, I want you to be very comfortable with the questions they ask you on your ACT. All right, let's read. The following chart represents the final course grades for students in 2 math classes. What fraction of students in the courses received a final grade of A or B? All right, we need to know the total number in our classes. So if we add up 5 plus 15 plus 20, I'm adding these, to get my total number of students, okay, then I see that I have 45 students total. And we want to know the fraction, okay, fraction is going to be our answer, the fraction that received an A or a B. So if I add together the number of A and B, that's 20 out of the 45 that made an A or a B. Okay? So the total always goes on the bottom, and the specific number that you're talking about or referring to is going to go on the top. So if I look at my choices, which I cut off here inadvertently, if I looked at the choices, I would see that 20 over 45 is not a choice. They're going to reduce this. So 4/9 is your fraction. (42) The following circle graph represents the distribution of students in a local high school. If there are 1,000 total students in the high school, how many more are 9th graders than 11th graders? So what we've got to do is find how many 9th graders there are, okay, the number of 9th graders, and subtract the number of 11th graders. That's what the question has asked us to do. So as we look at our chart, we see the symbol for 9th graders. So that means over here's 9th grade. So 45% of the 1,000 students are 9th graders. When you hear the word of in mathematics, you know you're going to multiply. So 45% of, and notice I changed that percent to a decimal. But we don't do arithmetic with percentages. We change percentages to decimals before we do arithmetic. So my 45% of 1,000, that's going to give me how many 9th graders I have, which I'm just going to move my decimal 3 places. That's going to give me 450. If you don't remember how to do that, use your calculator. Take advantage of that opportunity. And then for my 9th grade, my 11th grade I need, those are the dotted, so that's that little slice of the pie. So I'm going to have 10%, or 0.10 of the 1,000. That's the number of my 11th graders. So again, multiplying, I'm going to move that decimal. I have 100 11th graders. I keep saying 10th graders. I don't know why. So when I take my 450 and subtract my 100, that leaves us with 350 difference, 350 more freshmen than we have 11th graders. And that's what they ask us. How many more? Okay. Then 47, I'm kind of putting a little capstone here. We began with greatest common factor. Today we're going to end with least common multiple, your LCM. Here you're looking for the smallest number that each of these numbers will go into evenly. So we want the smallest number that 12, 20, and 40 will go into evenly. Okay? One way to do that, the way that I like to do it, I like to take my largest number, which in this case is 40, and start writing its multiples. So I'm going to take 40. 40 times 1 is 40. Now, will 20 and 12 go into 40 evenly? No. So then I take my second multiple. 40 times 2 is 80. Will 12, 20, and 40 all three go into 80 evenly? No. So I take my next one, 120. Will 40, 20, and 12 go into 120 evenly? Yes. That's the smallest one. So I know that B has to be my answer. If you don't like that process, if you don't like taking the largest one and looking at its multiples, you can always write out the multiples. Take your 12, your 20, and your 40 and write out the multiples. You know, you may have to go out 10 or 12 on these before you find them. Just keep listing them until you come out here and you find the 120. Okay? Another approach, we can use our calculator, and I don't have my calculator on this particular video, so I'm not going to show you that here, but we can look at that in class. Okay? All right, that ends this little session. Thanks a lot, guys.